A rectangular in-ground pool is modeled by the prism below. The inside of the pool is 16 feet wide and 35 feet long. The pool has a shallow end and a deep end, with a sloped floor connecting the two ends. Without water, the shallow end is 9 feet long and 4.5 feet deep, and the deep end of the pool is 12.5 feet long. If the sloped floor has an angle of depression of 16.5 degrees, what is the depth of the pool at the deep end to the nearest tenth of a foot? Find the volume of the inside of the pool to the nearest cubic foot. A garden hose is used to fill the pool. Water comes out of the hose at a rate of 10.5 gallons per minute. How much time to the nearest hour will it take to fill the pool 6 inches from the top, provided that 1 cubic feet is equal to 7.48 gallons? So there's a lot of information, especially coming from the first paragraph there. However, all the information from the first paragraph, there's not much to interpret considering all the information is already drawn and labeled in the diagram here. The second paragraph here illustrates there are actually 3 different components to this problem. We're going to go through this one at a time. So the question that's highlighted in pink there, we have to find out what is the depth of the pool from the deep end. Now, to do this, I'm going to label the diagram. In addition to the dimensions that are already given to us, I'm going to draw in these auxiliary lines to help us out with determining the dimensions of for the depth of the pool. So in order for me to figure out what the depth of the pool is, that's this guy right here, I need to know the following dimension. I need to know this height that I am going to highlight in blue here. I need to know this height. Whoops. I need to know this height. And in addition, I need to know this height. So there are 2 different heights that I need to figure out. Okay. Lucky for us, based on the problem description, the dimension that I highlighted in pink there, the shorter dimension that I highlighted in pink, that's already known. That's 4.5. Right? So, however, I need to figure out the dimension in blue there. But in order for me to figure that out, I need to know a little something about the right triangle that's inside. Right? That has the angle of 16.5. So looking at this, I noticed something else, that this dimension that I'm going to highlight in, let's say orange, that this dimension here is equivalent to 9. And then I have this dimension is equivalent to 12.5. So this is going to be 9. This is going to be 12.5. And then the only dimension that I don't know is this guy right here. I'm going to call A. And A is going to be equivalent to this guy right there. That's also A, because this is a rectangle here. So this quadrilateral is a rectangle. All right. So knowing that, okay, let's find out what is the dimension for A. And once I know what A is, then I can figure out that little segment inside, right, where the pool becomes deeper. So I know that 9 plus A plus 12.5 is equal to 35. I want to combine like terms. So I have A plus 9 plus 12.5, that's 21.5. And then if I subtract both sides by A, I'm sorry, not by A, by 21.5, what will that get me? Well, that will get me, let's see, 8.5 plus 5, that would be 13.5. So A is 13.5. So if A is 13.5, I'm dealing with a right triangle with the following dimensions then. Ice cream truck in the background is coming by my neighborhood. So I have 16.5 degrees over here. A is 13.5. And I'm looking for this dimension, which I'm going to call H. So h right now is opposite of 16.5, and 13.5 is adjacent to 16.5 degrees. So therefore, I'm going to use a tangent ratio. So the tangent of 16.5 is equal to h over 13.5. I'm going to cross multiply both sides, so I got h is equal to 13.5 times tangent of 16.5. I'm going to enter this into the calculator. So 16.5, I'm sorry, tangent of 16.5 times 13.5. Make sure your calculator setting is set to degrees, third row, second option there, and I'm going to press enter. So we get 3.998, or approximately close to 4, right? So 3.998, or h is equal to 3.998, or pretty much it's 4, right? And so the depth of the pool then, the depth of the pool will be is equal to 4 plus 4.5, which is equal to 8.5 feet. So we just answered the first question out of 3. The next is we got to find the volume of the inside of the pool to the nearest cubic foot. So to do that, we're going to break this thing up into different portions here. So I am going to, let me just zoom out a little bit. I'm going to erase some of this. And to find out what the volume of the pool is, what I'm going to do is I am going to subdivide this into the following regions. So what I end up with is 2 rectangular prisms and 1 triangular prism. So I'm going to find the volume of the large triangular prism, large rectangular prism first, because that's that dimension is already known. It's 4.5 times 16 times 35. So the volume is 4.5 times 16 times 35. That's the volume of the top rectangular prism. The next thing I'm going to do is I'm going to find the volume of the small rectangular prism, and just highlight which one I'm talking about. I'm talking about this guy over here. So all of that. Okay, I'm going to try to figure out what that is now. So that is going to be, whoops, I did not mean to do that. So that is going to be 12.5 times, well, we found this dimension here just a moment ago, didn't we? We found that to be 4. So this is 4, right? And then the width of this is also going to be 16 because of this dimension over here. So 12.5 times 4 times 16. So 12.5 times 4 times 16. So that's the volume of that rectangular prism. And the last one that I'm going to figure out is the triangular prism. So the triangular prism, I was able to determine the dimension of A, which this was 13.5 right here, and this was 4, and the depth was 16. So to find the volume of the triangular prism, I am going to do 1/2 of 13.5 times 4. This is the area of the triangle, times 16. So I'm going to enter this all into the calculator. So 4.5 times 16 times 35. Plus 12.5 times 4 times 16. Plus 0.5 times 13.5 times 4 times 16. Right? That's the volume of the triangular prism. So all of that is 3752. So this will be 3752 cubic feet. Okay. All right, so this is the second part that I just answered. Let's try to answer the next part now, the one highlighted in green. So we want to fill this pool up so that there is water with 6 inches from the top, right? So that means this volume that I have right now, I will need to subtract that by 6 inches from the top. So that means I need to subtract 6 inches is really half a foot, right? So 0.5, that's the height, times the width, times the length. So I am going to shave off that much, okay, from the total volume of the pool. So this will give me, so 3752 minus 1/2 of 16 times 35. So I'm going to go to the calculator. So minus 0.5 times 16 times 35. That will be 3472. This is the volume of water in the pool. So what I want to do with this is I want to convert this to gallons. So then I can then determine how much time it will take to fill this thing up, because it takes the hose is able to bring in 10.5 gallons per minute, right? So I want to convert this into gallons first. So 3472 cubic feet. 3472 cubic feet. Convert that into gallons. Whoops. Convert that into gallons. So I know that in 1 cubic feet there is 7.48 gallons. So I know the 7.48 gallons should be up top, and 1 cubic feet should be in the bottom. So I'm going to take that number that I found a moment ago, and I'm going to multiply that by 7.48. And that would be 25,970.56. 25,970.56 gallons of water. And since the hose is able to do 10.5 gallons per minute, so I'm going to take 25,970.56 gallons, and I know that the hose is able to fill 10.5 gallons in 1 minute. I want the time at the end to not be in minutes, but to be in hours. So I know that there's 60 minutes in 1 hour. So this is what I'm going to be doing, right? The gallons will cancel out. The minutes will cancel out. The final number will be in hours. So I'm going to take that 25,970.56 and divide that by the product of 10.5 times 60. So I'm going to go over here. So divide it by 10.5 times 60. And that will be 41 hours. Oh my goodness, that's a long time. Okay. So 41 hours. 41.2 hours. It says right here to the nearest hour. So it's just going to be 41 hours then. Is the final answer there.